Yeah, thank you, Yuan, for inviting me to this IPv6 Summit Vietnam, a milestone in your great efforts in the last couple of years, if not decades. And I would like to share with you, I wish I could have been with you in person. I would have loved to join your great stakeholders, as well as the many people that have been pushing Vietnam to be among the top 10 in the world. I've got some slides to share with you. So basically, I would like to touch on the impact of IPv6 on IoT, cloud computing, 5G, and blockchain. Blockchain is a newcomer. I think it will be an excellent end-to-end solution down the road. So basically, the ARPANET, if we look at the internet generations, we didn't have basically just three, there are five. So basically, ARPANET with 2 to the power of 8, which is NCP, Network Control Protocol, addresses just 256, and everyone thought, this is good for a research project. And in the meantime, Bobcat and Windsurf worked on their famous paper in 71, but published in 74. And it took them about 10 years now to get everyone to be on board in 81 to 85. But then the US government and some other stakeholders decided to move to OSI basically from 85 to 91, which stopped the internet for about 6 years. So I guess some of you remember the X25 and ATM times. And it's basically Bobcat and Windsurf started lobbying the industry and made the internet to be an industry initiative, which worked very well, especially that the same industry, they were against it at the beginning. But during the election of Bill Clinton and Al Gore, so they convinced Al Gore in order to push the internet and open NSFNet. So in the elections, he said that he's the inventor of the internet. So fake news existed a long time ago, so there's nothing new. And then V6 won against V7, V8, and V9. As a matter of fact, V7 was the OSI version of it. So we were a small group of developing IPv6, but a larger group was involved in the other versions. So that most probably was a little problem at the beginning, not to have full support for IPv6 from everyone. But in the meantime, we're still dragging our feet with IPv4 and NAT, and especially NAT has been sneaked into the telecom world. So basically creating a telecom internet. It's no more the internet as such. So with IPv6, we restore it. We go back to the IPv6 only internet in the next 5 years, primarily, in order to basically have a better control of the network deployment, and also include new versions, new functions, such as SRv6, so segment routing for V6, VNNIC for multicast, as well as blockchain and gaming. So all these things that need end-to-end access. So primarily V4, we managed to do 1 billion nodes, and with V6, we go to multi-billion nodes. We need for that the always-on identity with the privacy at the same time, but the auto-configuration is fundamental not to deploy large networks like IoT networks. And we'll move from broadcast to multicast. Broadcast is not very good for spectrum, so 4G, 5G spectrum is eaten up by 50% of it just to send the packets. And mobility, we have created already the success story back in 2000, May 10th, when we specified IPv6 for 3G, but we didn't have the products and the services, and they trained the personnel to deploy that. So they reverted to IPv4, although at the beginning they wanted to use WEP, which is the wireless access protocol, which most probably would have been single proprietary internet services for each ISP without being connected to the internet. And we managed to kick that out. So always on security privacy, there's a bit of work to be done in this area. Recently, Europol has mandated to move away from carrier-grade NAT, or at least to reduce the number of people to be accessing a single IP address to 12, as some criminals have been identified but unfortunately they picked up the wrong guys. So that was the reason why Europol has got involved, to correct that mistake. So the end-to-end model is really fundamental, and its restoration is what we are using today for the enterprise that can have get routable address space, or the big servers that do have that. But we have to do not only the peering at the top, we have to do the peering at the bottom as well. And this is where really the internet innovation will come back and will be resurrected fundamentally. And if we look at the Gartner hype cycle, we see that IPv6 now is in the move upwards, although most of these organizations don't understand how the internet functions, but they're picking up some of the stuff there as well. So in the meantime, by end of May, we already achieved 50% with 2.5 billion IPv6 users, primarily because the China numbers were not included. So the 435 in the meantime, it's 500 million IPv6 users in China. And, all the IPv6 users don't even know that. And that's a good thing. But for the developers, they should understand that now they have access to routable IP address space, and that is really fundamental. So congratulations to Vietnam for having 50% penetration in V6 with 28 million users, which basically makes Asia the hub for IPv6. If not, it would be the biggest internet in the world using IPv6, so most probably 2/3, if not even more, down the road. This is really a great achievement, and it fitted a long time ago in our strategy to go back to countries that didn't have V4 address space and basically motivate them and show them some best practices and deployment scenarios in order to deploy IPv6 in Asia. And I think we've been successful in doing that, not only in Asia, but also in Latin America. Obviously, we have a bit of work to be done in Africa. But that's not a story. So basically, if you are using NAT, which is the entire planet is using NAT, we are all still in the luggage class as such. Only the servers and routers are using IPv4 routable address space. But if you are using IPv6 today, and most probably you do, since you are in Asia, especially in Vietnam, you're already in business class. And by combining IPv6 with 5G, cloud computing, IoT, and blockchain, you basically get into the first class service. So looking at the web generation, so Web 1.0 invented by Tim Berners-Lee at the CERN Center. And then later on, Tim O'Reilly started Web 2.0, but it was only a series of conferences basically showing the interactive internet, so the Facebook time and YouTube and so on and so forth. But there is no standard behind it, so it's a fake protocol, and we're going to see its repeat again. So Tim Berners-Lee started working on the semantic web, which is basically Web 3.0. So a lot of people don't even realize that Web 3 already exists, invented by W3C. And Dave Raggett has been working with us on the web for IoT devices because XML is too heavy for IoT devices. And as you see now, you've got Web 3. Like they should know, they should call it Web 4 at least. But someone is already proposing Web 5. These are still not standardized protocols. Same thing applies to metaverse. So in order to make them really accessible to everyone, so these guys have to talk to Tim Berners-Lee and to make them standardizable. Otherwise, we'll end up into a nightmare of proprietary solutions, which is not good for the planet. Wireless generations, I won't go into these details, but since 3G, we have put IPv6 there, but in the meantime, they use IPv4 and NAT, unfortunately, especially in 4G, because you can do end-to-end calls or whatever services. And in the meantime, 5G has picked up IPv6, especially the standalone version. And the reason for it is that 3G and 4G, especially 4G, the voice was not defined right from the beginning, only later on. So a lot of operators are using 3G for voice and 4G for the internet, for data. And in 5G, they didn't do that mistake. But still, you have non-standalone, which includes in this case 4G and 3G, but standalone does IPv6 only. So this is where IPv6 is used, especially in places like in the US. You take T-Mobile, they have used IPv6 only and standalone only. But they have their niche, which is basically going after the enterprise instead of doing just Wi-Fi coast to coast. So you'll see a lot of verticals going to 5G in this area. And 6G is coming up, but it has not a very good spectrum, especially terahertz. It's primarily made for indoor, although you get terabit access as such, but it does not cross walls and windows. And outside, if it rains or leaves are coming down, it disrupts the communication. So we are gone for 5G for a long time, and 6G would be complementary to 5G. But it has very important deeper verticals, especially in assembly lines that need fiber optic, or in data centers where the big mainframes, whatever data servers are hooked with spaghetti fiber. You can just use, in this case, terahertz modems for that purpose. So IoT generation. So we have small fake news with Kevin Ashton. He was the marketing manager of the MIT RFID Center, where in a press conference, labeled the RFID as the network of things, or Internet of Things, although it's just network of things. Until today, there's no RFID with an IPv4 stack or NAT stack or even IPv6 stack. But it created the big buzz. So everyone talking about Internet of Things without knowing that it's not supported. It's not supporting IPv4 and v6 the way it should be. So it's for IoT too. It's one-way gateways, and the move is to go to two-way or things to things, especially when you have zillions of each guys talking to each other and then just synthesizing the decision making that you want to do that. So it would be the smarter IoT devices or sensors, whatever you call them, supporting IPv6. And then cloud computing. Interesting thing is that two South Africans, Pinkham and Van Billion, have invented the elastic IP solution, which Amazon has hired them for that purpose back in 2006. And they deployed the AWS, which is proprietary so far. And I doubt they move to open it using OpenStack or similar. So cloud computing 3 is a fundamental next step to move to data transparent cloud services. And the European Commission has just started the Gaiax Initiative, to get the data to be basically archived and safeguarded in the country. That's why Gaia stands for the Greek Earth. So it should be earthed in its country. Otherwise, if they are saved back into the US, due to the Cloud Act, basically data is open. So I'm moving directly to a new topic, which is basically blockchain. So blockchain is a peer-to-peer application, kind of copied from BitTorrent, but it's using today IPv4, if not NAT. So they have to traverse these NAT, to make these things happen. So the mining servers, and there are 7 of them, but it's not really decentralized. It's fairly centralized. So the noise we hear from this multi-million people working on it is quite astonishing. So it needs a proper end-to-end secure routing to do that. So back in July 2017, the keys of BTC, so Bitcoin, has been hacked, and then it went up from 20K to 3K in 1 week. So I was looking into a project. I have a new project called Cities 2030, where we are looking at blockchain in the food supply chain, and to see how we can track and trace products from the farms to the forks. And by looking into if somebody has been doing some work on this one, so I got into this Australian guy called Dr. Craig Wright, and in one of his papers he was showing that he's doing more research or further research into peer-to-peer systems, IPv6 and Bitcoin. And I dropped him an email and he responded right away. So that was back in December. Since then, we have been doing a lot of activities together, a lot of fun And I think his approach is very important. So basically, it's against the current Bitcoin, worldwide scam, if not Ponzi scams, the Ponzi deals that are happening. His invention was basically to do normal digital cash, so that everyone can buy and sell his products, from the farmers to the small people and so forth. And this is not happening. So he's reviewing it by calling it BSV, which is a Bitcoin Satoshi vision. This takes us back to the digital cash. And we have been looking at blockchain and its hype cycle from the Gartner Group and cryptocurrencies, and the blockchain area is now bouncing up on this S-curve. And it's very important to look at the fundamental use of blockchain in the future, especially in the contracts for private, so in order to get the digital notary to be digitized and also secured, so that encryption can be used, especially in the contracts for buying houses and selling, plots of land and so on. There's still a lot of speculation happening there. And then if we fix also the security of digital keys, I think we can use blockchain into smart cities, IoT, by government, health. But there are many applications now running using exactly BSV blockchain in the Emirates, to make sure that the diplomas of engineers are real, they're not fake, and we know that a large number of diplomas around the world are fake. So there are many areas where the blockchain can be used for, on top of the the usual stuff for the supply chain, where we have also found that the food supply chain is really corrupt. So guys in between are buying products from the farmers for a very low price and selling them for 3 to 4 times. This is really not necessary, and it is having an impact on the health of the people as well. So that's production is done massively using all kind of fertilizers and all kind of not healthy medicine to kill all kind of insects and so forth. So we have this HC group, which is basically complementary to the ITF work. The ITF looks at protocols, and here we're looking at use cases and best practices and practice guides. So we have in the meantime, about 90 members, and we are putting together a certain number of papers. So deployment of IPv6 in the different sectors, in the verticals, as well as in governments, and the role of regulators in the various countries. So it's very important to join this one. It's free of charge for those that want to be just participating as well. You can also contribute with papers and join this one. And this we have used back in '99, to get the wireless internet revolution by adding IPv6 to 3G, although later on, as I mentioned earlier on, they couldn't get products on IPv6, so they evolved it to IPv4. It took about 10 years until we get 4G, as well as IPv6 routers and servers running. So I think we're going to repeat the same story with blockchain in this area. So quickly, by 2025, we will have the first batch of IPv6 on the internet. So primarily US government, like the US and the German governments are doing that, becoming leader with the registries to have their own IPv6 address space, so that they have their own basically data sovereignty, and also access end-to-end between the millions of networks among each other, especially in the US. And the top 100 5G SA will be deploying IPv6. The top 1,000 will be doing IPv6 in terms of websites. The enterprise, we expect in 5 years now, the top 1,000 enterprise will be using cloud, to get V6 service. And we saw that with the Cloudflare doing a very good job for smaller companies, for SMEs and so on. And in terms of apps, BSV blockchain is going to be the major winner in this. As a matter of fact, we have with us today Jimmy, and he's the founding president of the Blockchain Association. He's going to go into more detail on what is blockchain, what is BSV, and what is blockchain, but also applications like gaming, conferences. Zoom should be doing IPv6 end-to-end, but we will have not a digital divide between those that have IPv6 only, 25%, 50% will be on dual stack, and 25%, unfortunately, will be on IPv4. So it will take us most probably 10 years not to get everyone on IPv6 only. So, coincidence between Windsurf and Bobcan and Craig. It's basically, the paper from 1974 describing TCP/IP, and now we're saying, let's go for V6. And now it's Craig who is promoting IPv6 for blockchain in his paper dating back to 2008. So I think Greg is going to give us a new, fresh start with the blockchain on the internet, and most probably will be a big story in the future. Have a great conference. Thank you.